After opening the Answers workbench, today we are going to do Campbell Airfoil. So we have to select Fluid Flow. In this, select the Geometry option and select the New Design Model. After selecting the New Design Model, first we have to change the units in the millimeters here. And then select the XY plane. Now the XY plane is selected. Now we have to generate the points. So that I am taking points. I am taking NACA 2412 airfoil points. And now here we have to click the generate option so that our airfoil is generated here. And now go to concept, 3D curve. We have to select each and every point from here. While selecting the points, we must be carefully select the points. If one point is not selected, the airfoil may generate wrong. 1 second. See, at last we are having one more point here. So that I'm selecting at this point. And now to join these 2 points, we cannot join directly. So right click here, close. So the airfoil is generated. Now generate airfoil. And the concept, surface from edge. Select the airfoil, apply, and generate. The airfoil is generated. And in that plane, I'm going to offset it. Because the trailing edge I want the trailing edge this side, so I have generated like this. Now I am going to create a domain for this foil for this sketch, and I'm going to sketching option. After that, arc by center. Exactly from this center, I am going to draw an arc to this. And now arc is done. I am taking rectangle by the 3 point so that drawing it. Now I'm going to trim the extra unwanted lines. This is the unwanted line we are having. Just I'm trimming that. And now go to dimensions. And now I am taking this as 5 mm and this as 10 mm. You can take your own dimensions, no problem. So the domain is generated here. Now go to concept, surface from sketching, select the sketch, apply, and now generate. So the domain is generated. Now we have to apply some. You can also add the material, but we are having only concept. I'm adding that. So the material is added to this. And now I'm going to create option in this boolean. Now we have to separate the air separate the material that which is inside this airfoil. For this, we are going to do the boolean option. Target body is the whole the whole domain we are selecting, and the tool body, so we are going to select the airfoil here. So this is the airfoil, and this is selected. This is not selected. Apply. So the both are applied, and you can see here. Wait a second. The material in this airfoil is completely removed now. So that after doing till here, the domain is generated, everything is done. But we have to do, if we select the domain, it is selecting the whole domain, but we want the individual domains. For that, I am separating the lines. So select a new sketch. Again, go to sketching option. I'm selecting the line here. So I'm drawing one horizontal and one vertical line over here. So the extra line which over there, I'm going to trim it. So the lines are trimmed. Okay. Now go to concept, line from sketches, select the sketch 3, so the highlighted, apply, and now generate. So the lines which are drawn are highlighted now. So that now I'm going to tooling option. In this, the projection we have to select. The edges are which the lines we have drawn now. We have to select whole 4 lines and apply. The target body is the whole body. We have to select, apply, and now generate. Now see, you can see here the domain is separated. So the now geometry part is done. So design model. And now I'm going to mesh. Select the mesh option here. So the mesh is open now. Again, we have to select only XY plane even in this. So directly once generate mesh, so that the mesh will be generated over here. You can see, and right click, insert, face meshing option. You have to select the 4 left bodies, apply, and again right click here, go to sizing, and now we have to select the corner option here. So I have selected the corner option, and I'm selecting these 2 corners which are also called as inlet. Now apply. The material size I am taking as number of divisions, and I am giving as 50. In the same way, again right click, insert, sizing. Now I'm going to select these 3 lines, apply, same number of divisions. I'm going to give as 100 divisions. So this is generated. And again going to sizing. Now I'm going to select these 4 lines, apply, number of divisions I'm giving as 50, enter. Then this is done. Now we have to give the name. For naming, I'm going to select again these 2 edges, so that if we right click here, we will get a name option. So I'm giving it as inlet, and I'm selecting these 2 edges, so that I'm giving it as wall, enter. And again, I'm selecting these two and I'm naming it as my outlet. And also here we have to select the airfoil also, airfoil edges, and we have to name it as airfoil. And now everything is done. Once you can see the, if we select inlet, the inlet part will be highlighted, walls, walls will be highlighted, outlet, and the airfoil. So this is done. Now right click on the mesh and generate mesh. So the mesh is generated now. So the mesh part is done. We can close the meshing and set up. The mesh, we have done some mistake. So for edit this again, we have to come here. I have not updated the mesh. If anything wrong we have done, it will show the tick mark over there. So now I'm right clicking the mesh, update. So the mesh transition is successful. Now close the meshing part. Now you can observe the tick mark over here. If you won't get the tick mark over there, it means we haven't. See now, you have to select double precision and OK. So that the setup part will be open now. So as the setup part is open, we have to see the options that type is pressure based and velocity formation is absolute. As these all are correct, directly I'm going to model and select here energy. I'm taking energy equation. Okay. Next, viscous lamina I'm going to take in this. We are going to do an invisit over here. So I'm taking invisit and click OK over here. So the modeling part is done. So material selection, I'm going to take fluid. In that, I'm going to take air. Here the density is 1.25, it is correct, and the specific heat is 1006.4. So even it is correct. So you can close this directly. If there is any changes, you have to adjust the values, change or create, then close the option. Now it is correct. I'm not going to change any option over there. Directly I'm going to boundary conditions. In boundary conditions, I'm going to take inlet as my boundary. So in this inlet, I'm changing this to magnitude and direction, and I'm giving velocity magnitude as 150. Click OK. Now the boundary condition is also done. And now I'm going to do insulation. Insulation, we are going to select standard insulation. Compute from, I'm taking it as inlet. Everything is done and the gas pressure should be always zero in this particular case. And this is everything is correct. Initialize and now run calibration. Here, number of iterations I'm giving as 100. It depends on you. You can as you wish calculate. So you can see here is the calculation, the graph. Once the calculation is done, we will get calculation is completed. So okay. Now I'm going to graphics. In graphics, I'm going to oops. So here the options. These four should be only selected. Other than this, we should not select any other. And here the all five options should be selected. And now pressure and static pressure. So save and display. So we will get here. You can observe. So you can observe the domain. The pressure is created at the airfoil. So now I am changing this pressure to velocity and the same way save and display. You can see the velocity change over here, and when this is done, the setup part is also done. So we can press the event, click OK over here. So now the last step, that is result. Same, right click on the result option. Get the line which we have created now. So again select as XY plane. In this I am going to streamline. I'm going to select the streamline. Okay. And start from inlet. Inlet. And points I'm giving as 100. So equal spaced. So now this is generated. You can see the animation video also. Select the streamline. Play. See the flow, so how it is flowing. It is done. So it is done.